Hey guys, today we are looking at lesson 2.7, graphing linear equations from point-slope form. We're still going to be working on identifying those key features, but those key features have not changed. They're still slope, y-intercept, and the x-intercept. So point-slope looks a little bit different, so we're going to need to be able to do some things. One, can we identify slope from point-slope form? This was actually a question on your last test. So you've kind of seen it before. You should be able to identify a point that's in the form of x1, y1 in point-slope form, and you should be able to plot that point and then use the slope to move. So we're always going to start with a point. With slope-intercept, we'd started with our b, that y-intercept point, and then we used our slope to move. Now we're going to be starting with a specific point and then still moving with our slope. Okay? So graphing now point-slope form gives you a point and a slope. So let's talk about where those point and slope are in the point-slope form. So you see the formula or the equation that you have. It says y minus y1 equals m parentheses x minus x1, close parentheses. The m is our slope. Okay? The m is our slope. It comes right in front of the parentheses, and it's still pretty close to that x value. It's right. The x is right after the parentheses. Okay? So slope comes right before the parentheses in point-slope form. It'll always be right outside of it. If there's nothing right outside the parentheses, then the slope is 1. If it's just a negative right outside the parentheses, then the slope is -1. Right? And then the point is found in two separate places. And remember up at the top there, I said that your point is in the form of x1, comma, y1, where your x1 is your x value and your y1 is your y value. The reason they have those ones is because we already have an x and a y in our equation, because you have to, in order to have a line, you have to have an x and a y. Remember, we plug in an input and get out an output. So by identifying it with a 1, x1, y1, it says, okay, we're actually going to have a point in these spots. So in these two spots, this x1 spot and the y1 spot, just like with the m, we're going to have actual numbers plugged in. Okay, so that x1, that's my x value in the point. And then my y1, that's my y value for the point. Right, they're going to come together to make that point x1, y1. Okay, something important to note about this is the minus signs right there. They are part of the formula. So y minus my y1 value. This can appear differently if we have a negative y value or a negative x value. Because instead of seeing it as x minus my negative, say, 3, normally you would just see it as x plus 3. So sometimes this formula can look a little different, but just note kind of that the minus sign is a part of the formula. And so that can kind of make things a little bit difficult when you're pulling out the y value. The y value doesn't really go with the sign, or it's the opposite of the sign, if you want to look at it that way. So in order to graph from point-slope form, we have to be able to identify the slope, identify the point, x1, y1, plot that point, just start with the point, then use that slope to plot more points and connect them with a line, and then we can identify those key features. So let's take a look at just identifying some points. So on these few examples, you're going to be asked to identify the slope and the point. Okay, I'm going to go over a couple with you that I think are a little bit tricky, and then I'm going to leave the rest of them for you to just get some more practice if you think you need practice identifying. We're going to look at that first one. Y plus 1 equals 2/5 x minus 2. Okay, it might be helpful to write y minus y1 equals m parentheses x minus x1 over the top of your equation. That way you can kind of see where everything goes. This won't really change order like maybe it would with the slope-intercept. I can see my slope right there in front of the parentheses is 2/5. And what's going to be tricky is looking at my point. So I see my point here, my x value should be there, my y value should be there. But here's what I'm going to notice about my y value. My y value now says y plus 1, but the formula is y minus 1. This means that we have a y minus a negative 1. So you can always look at the opposite value. Because it says x minus 2, we're going to take out a positive 2. So when looking at the point, and maybe you want to write this down, but when looking at the point, you want to take the opposite of each value. So I just wrote, when looking at the x and y values, take the opposite. That means if it says x minus 2, the point you're going to take out is a positive 2, because it said minus 2. So that's going to be the x value. Okay? And then it says y plus 1, so I'm going to take the opposite of plus 1, which is going to be negative 1, and there I have my point. Okay? Make sure you notice that the x value is right next to the x, and the y value is next to the y. Okay, I know they're written kind of in backwards order, right, because you're going to see that y value first, but make sure you put it as the x, or as the y value in this second space there. Okay? We're going to look at a couple more. Let's look at the third one over there, that top right corner. The y plus 5 equals negative parentheses x plus 9. When you see a negative outside of parentheses, hopefully you now realize, because we've dealt with this a lot, it means it's a negative 1, which then means that my slope is negative 1. Okay, when looking at my point, I'm going to pull out the opposite of this value and this value. Because they're both positive, they're going to be both negative. That's next to my x value, so it'll be my x. That's next to my y, so it'll be my y value. So negative 9, negative 5 is that point. All right, going to look at just one more, that bottom left corner. It says y minus 16 equals parentheses x minus 24. Oh no, there's nothing out here right in front of the parentheses. What do? That's just like there's a 1 there. So my slope is 1. Now I'm going to take the opposite of negative 16 and negative 24 for my x and my y values. The opposite of negative 24 is 24. The opposite of negative 16 is 16. So there we go. Remember, guys, this is the first step. If we can identify both the slope and the point, then we can use them to graph, starting with that point. So let's go ahead and get started with that. So example 1 says to graph the following function. Y minus 3 equals negative 3 halves, parentheses, x plus 4. First thing I notice is I have parentheses in this, and I have a value over there on the left side with my y. This tells me that I'm in point slope form. So we're going to follow the steps, identifying slope. Those steps are right up here. Oops. Right up there. By identifying the slope, identifying the point, and then plotting the point, and then moving with the slope. So I have a space to identify both the slope and the point. I see right here my slope is negative 3 halves. Perfect. It's already in fraction form for me. And then my point, the opposite of 4. So negative 4. And then the opposite of negative 3, which is 3. Fantastic. Now that we have that, we can plot the point. So start with plotting the point. Start here. So I'm going to go to my graph and I'm going to plot negative 4, 3, right there. And then from there, I'm going to use my rise over my run, my slope, to create another point. So my slope was negative 3 halves, which means I'm going to go down and I'm going to go to the right. So I'm going to use orange to kind of show that. I'm going to go down 3, 1, 2, 3, and I'm going to go to the right 2, 1, 2. And that is where my point should be. Now, you definitely don't have to have those orange dots on there, or, you know, whatever color you want on there. Okay, that was just kind of illustrate I'm doing that rise over my run. Now, I have 2 points. That's really all I need to do. If I want to do more, I can. I'm going to do some more just because I feel more comfortable with that. You can see as I added more points, I actually went another direction. This, remember, right here was my original point. I actually went one backwards just by going up 3 and then to the left. But by doing so, I now have a nice and pretty line, and I can identify those key features. We've already identified the slope, so let's just identify the y-intercept, and you have a spot for this, but I don't, and the x-intercept. So that y-intercept looks to be right here at -2, so I'm going to write is 0, -2, and my x-intercept, it looks to be right there at -2 as well. And the x-intercept is -2, 0. Let's look at one more example. Y plus 2 equals 2 parentheses x plus 3. That slope is 2. Let's make that into a fraction by putting 2 over 1. And then let's go ahead and just say that means we're going to go up 2 and then to the right 1. Now, looking at the point, we need the opposite of +3 and the opposite of +2, which gives us a point of -3, -2. Let's start with this point. We're going to start here. Let's plot -3, -2, and then use our slope to move it. Go ahead and do it and see, pause it and try it, and then come back and see if you got it right. So there is my graph. I plotted that original point right there, -3, 2, and I went up 2 over 1 to the right. Now all I have to do is identify those x and y intercepts right there and right there, and we are good to go. That means my y-intercept is 0, 4. My x-intercept is -2, 0, just like it was last time. Okay, go ahead and grab the practice and let your teacher know if you have any questions. But we're going to start with that point, move with the slope.